Hello everyone, I am Manaswee Saha and today I am excited to present my project EcoSense, a real-time environmental data logger. The goal of this project is to develop a smart real-time and monitoring system that can track environmental parameters using sensors, Arduino and MATLAB. This system is particularly useful for smart homes, industrial settings, and scientific research. So, what does an EcoSense monitor? EcoSense monitor light intensity using an LDR. LDR means the light dependent resistor. With this one, you can measure your light intensity in MATLAB. So this is an LDR. One end of LDR is connected to the 5-volt power supply. Another end of the LDR is series connected to a resistor, and the other end of that resistor is connected to the ground. We connect the analog input of the Arduino uh, to the LDR. And then the second sensor is the DHT11. This is a temperature and humidity sensor. So there are three ports of this one. One port is connected to the ground. The red port is connected to the 5-volt power supply, and the middle port is connected to the analog input of the Arduino. The third sensor would be a microphone, like a sound level sensor. So this is a microphone, and this is like an variable resistor. From this we can measure we can set the sensitivity of the mic. So this one is this is a KY038 sound level sensor, and this is used to measure the sound level. How does it work? The sensors are all connected to the Arduino, and the Arduino Uno processes and transmits the data. This is the microcontroller of my project, an Arduino Uno R3, and this takes data from the sensors of the three different sensors and pass this data to the MATLAB that is connected to my computer. That is on my computer. The MATLAB reads and visualizes the data in graphs. In this video, we will cover a detailed look at the hardware setup, which I've already given a demo. Second, how the data is collected and transferred, and a live demonstration of sensor functionality in MATLAB. Real world, and fourth, real world application and future and improvements. So let's begin. Before we dive into the demonstration, let's take a closer look at the hardware setup or components that make up EcoSense. First, the microcontroller Arduino Uno R3. This is the brain of the system, responsible for reading sensor inputs and communicating with MATLAB. This is powered by USB connection to the laptop. Second, the sensors and their roles. The first sensor is the light dependent resistor LDR, which detects. So this is an LDR. This detects and logs ambient light intensity, which is useful in energy efficient lighting automation. Second sensor is DHT11, a temperature and humidity sensor. It measures temperature and humidity, which is ideal for this sensor is ideal for climate monitoring and HVAC systems. The third sensor would be a sound level sensor, like a sound level logger, that is KY038. With this captures ambient noise levels, and which is useful in environmental noise compliance and smart home automation. Third, data transmission and circuit design. All sensors are wired into Arduino Uno, which transmits data to the MATLAB. All sensors are wired to Arduino Uno, which transmits data to MATLAB over a USB serial interface. So this is the laptop, which is the MATLAB is running, and this is the graphs are the representation of the light intensity, temperature, humidity, and sound level of this system. So the circuit is originally built on breadboard and now is transferred to a solder to a perf board with soldered connection for improved durability. And the system is enclosed in a protective case. This is like the 10 centimeter length, 10 centimeter base, and the 6 centimeter of height to ensure portability and safety. Now that we understand the setup, let's see EcoSense in action. The system is now powered on and the MATLAB is ready to receive data. We will test each sensor under different conditions to verify its functionality. First, the light sensor LDR test. Right now, I have already pressed the monitor and tune button in the MATLAB. There you go. This is the light intensity scope. I'll press double click in here and then we can see the graph. So right now MATLAB graph shows the stable light intensity. You see? And then if I place my hand over the LDR, there is a sharp drop in the intensity, like a bit drop in the light intensity. And when I remove my hand, the values will return to the normal. For the second test, I've decided to use a torch. So I'll use a torch, and when I turn on the torch on the LDR, you can see a sharp rise in the light intensity graph. There you go. And then when I turn the torch off, this will go back to normal. Now we will test the temperature and humidity sensor DHT11. Currently, the temperature and humidity are on a certain level and like at a constant level. When I put the sensor in my hand, and you can see the changes in the graph. Or when I talk and breathe uh, near the sensor, the humidity level would change as well, as it will detect the moisture in my breath. There you go. Over time, it will stabilize back to the ambient room condition. And this is the final graph when the time goes out. This is the final graph of the temperature humidity sensor. You can see the changes in here. The third test will be the sound level sensor test, the KY038. So when the room is quiet and when I'm speaking in a certain sound level, the MATLAB graph shows a stable sound level. And when I snap or clap near the microphone, you can see the sudden rise in the MATLAB graph. And when I speak on the near the microphone, you can see the rise in the graph as well. And when I keep the microphone in the back in where it was, and when I'm not doing anything that would increase the sound level of the room, it goes back to the normal. Now, let's talk about the application and real-world use cases of EcoSense. EcoSense can be applied in multiple domains, to enhance efficiency and monitoring capabilities, like smart home automation. In smart home automation, you can adjust lighting, ventilation, and noise levels based on real-time conditions. And then environmental research, which can help scientists analyze our EcoSense can help scientists analyze climate trends and urban noise pollution. In industrial monitoring, EcoSense ensures workplace safety by monitoring noise and climate pollution. In academic and research use, a hands-on tool for learning IoT, sensor networks, and MATLAB application is really useful for today's generation. In conclusion, this video demonstration successfully verified that the EcoSense has met all its design specification and works perfectly well, and it accurately collects data from different sensors, and it transfers into the Arduino and transfers this data into the MATLAB in the laptop or any other computer, and the MATLAB will visualize those data and present them in a graph form. um, EcoSense works as expected with precise real-time data logging. MATLAB integration ensures reliable data visualization and trend analysis. The system is a valuable tool for all researchers, students, engineers, and students exploring sensor-based application. um, we can really learn how the sensors all works, and having Arduino Uno R3 as a microcontroller definitely broadened my knowledge as well. Thank you for watching, and if you have any questions, feel free to leave a comment or reach out to me at my email. My email is msaha@man.ca. Stay tuned for more updates. Thank you.